So what we're going to be looking at here is how to write ionic formulas. So basically, how to take a named compound and turn it into a chemical formula. So something you have to understand about ionic compounds is that the charges of the cations and the anions, they have to balance in order to give the overall charge of the molecule. So if you have a neutral ionic compound, the negative and positive charges, the total of those two charges must be equal. So if we look at an example here, if we look at magnesium bromide, okay, we know that magnesium bromide is going to consist of magnesium ions and bromide ions, okay? And we know that magnesium, from the periodic table, because it's in group 2 over here, is going to form a +2 charge, all right? Bromine, okay, is in this group over here, which gains 1 electron and forms a -1 charge. All these have a -1 charge when they form ions. So we know that our magnesium is +2, and we know that our bromine will turn into a bromide ion and subsequently be negatively charged. Okay, now, in order for these two ions to counterbalance each other, there's going to have to be a look at the amount of charge that each ion is contributing. Okay, magnesium has a +2 charge, the bromide ion has a -1 charge, so I need two bromides that are negatively charged in order to balance the +2 that's on the magnesium. So what ends up happening is that when I have my magnesium bromide formula, I'm going to write MgBr2. This subscript 2 is telling you that you have 2 bromine atoms for every 1 magnesium. Now that can be a little bit confusing for some people. So another way to approach these problems is something called the cross-down method. So what's the cross-down method? Basically, what you do is you take the components of the name. So aluminum and oxygen, they're going to combine to form aluminum oxide. So if I told you, hey, take aluminum oxide and turn it into its ionic formula. Okay, so I have this name and I want to go to formula. So what's the first thing I'm going to do? The first thing I'm going to do is I'm going to find the ion charges. Okay, so I have aluminum and I have oxygen, right? Aluminum, it's in this group over here, so it's going to form a +3 charge. Okay, so I write that aluminum, I write that cation and that metal ion first. And then oxygen, notice it's 2 away from its nearest noble gas, going to the right, so it's going to gain 2 electrons. So oxygen forms a 2-. Okay, so I found the two charges of my ions. Then what I'm going to do is I'm going to cross down. Okay, so what I'm going to do is I'm going to take the superscript for the 2-, and that is going to become the subscript for my aluminum. I'm going to take the superscript or the charge on the aluminum, and that's going to become my subscript for my oxygen. Notice I leave the the charges or the signs of the charges off. I just cross down the actual numeric value, and I now have the two subscripts. Now that I've brought down the 2, okay, that's saying I have 2 aluminums and 3 oxygens, I need to check if the subscripts can be reduced any. Okay, so I need to check them. Okay, can anything be divided into both 2 and 3 to give me whole number ratios? And the answer to that is no. Anything I divide 2 and 3 by will give me some sort of fraction. So this is my formula for aluminum oxide based on the cross-down method. So as a reminder, remember most ions in this group here form a +1. These are +2, +3, oops, okay, -3, -2, -1. Okay, now obviously we'll be talking about the other options that are present for each of these. There are different oxidation states, but these are the typical oxidation states that we're going to see. Also remember that the transition elements form multiple different oxidation states in most cases. But being familiar with these rows, or excuse me, these groups here, will allow you to answer most ionic nomenclature questions. So let's do a little bit of additional practice. Okay, lithium and bromine are what are the elements that are going to compose lithium bromide. Lithium forms a +1 charge, bromine forms a -1 charge. You cross down those ions, okay, and that's going to give you lithium bromide. Okay, this is your formula. Okay, aluminum, it forms a +3 charge. Sulfur, 2-. Cross down these charges. Okay, no reduction of the subscript is necessary because nothing will go in evenly. Okay, now if we look at a transition element containing compound, remember, anytime we see these parentheses, we know that that's indicating the charge on the transition element, on the transition metal. Okay, so iron in this case, they've told us, is +3. Oxygen is 2- because oxide is always 2-. Cross down these ions. Fe2O3, that can't be reduced anymore, so you have your appropriate formula. Once again, we're dealing with a transition metal element. Okay, they've told us that the charge is +2 because they gave us copper 2. Phosphorus is 3-. Cross down those two charges. Okay, so Cu3P. Okay, no reduction can occur of those subscripts, so that's our formula. And last but not least, we're going to look at manganese 2 oxide. So manganese is +2 because the +2 in the parentheses tells us the charge of the ion for the metal. Oxygen is a 2- charge. Notice we're going to cross these down. This gives me Mn2O2. Now these can be further reduced. 2 and 2 can both be divided in to each other, so our actual final answer will just be MnO for magnesium oxide. So these are just a few examples of modeling with the ionic compounds. This is utilizing the cross-down method to go from name to formula. Make sure that you're paying attention to your parentheses whenever there's a transition metal present. Remember that that indicates the charge on your cation, your metal ion. Okay, and also make sure that you guys are reducing down subscripts anytime something can be evenly divided by a common value.